Hello everybody, this lesson is going to be about balancing equations. This may have been something that you've done in middle school, and if it is, that's great. It means you don't have to learn something brand new, but you do need to focus on getting good enough at it that you can do it very quickly, and so that you can do harder examples of balancing equations. So we're going to start with just a couple of things that are probably review, some basics, a couple of key terms, things like that about equations in general. So first, just want to review some signs of a chemical reaction. Since we are starting the reaction chapter, I think it would be good to review the things you would see as evidence that a reaction occurred. Sometimes they're easy to see, sometimes they take special equipment, but something like these things listed here should be a sign that an actual chemical change has occurred. So for example, a color change, or maybe a gas is formed. It could be an odor change. The smell could start to be different. You could form what's called a precipitate. A precipitate is what you get when you pour two liquids together and all of a sudden a solid appears. The product that they make is now a solid, not a liquid. You could also have a change in energy that can be seen. You could be absorbing or releasing heat. Sometimes we may see that as having a flame, like a combustion reaction. We see something burning. Or you could release light. So if you've ever played with those glow sticks, like at Halloween, that's a chemical reaction that's occurring, and we can see light being released as evidence of that reaction. Just a reminder that we have the law of conservation of mass. When we do these chemical reactions, the total mass of what we start with should equal what we end with. Nothing can magically disappear, right? Or appear. We can't be making things appear out of nowhere. Remember that this is science, it's not magic. So we do need to make sure that we are conserving all of the matter on both sides of our reaction. Remember, in a nuclear reaction, you can convert it. So it may look like mass disappeared, but really you've just converted that into a different form. But since we're just doing a normal reaction, we don't need to worry about that. We have things called word equations, which is just like what it sounds like, where you have the words written out. Or you can have skeleton equations, which is what we call it when there's a formula. It would be nice if they just called it a formula equation, but they don't. It's called a skeleton equation. You can see those are both the same reaction. Hydrogen gas and chlorine gas combine to form hydrogen chloride gas. The things we start with on the left are called reactants. The things we end with on the right are called products. If you see in parentheses, sometimes they're called starting materials or ending materials. I have a habit of calling them that just because of the type of work I used to do before I was a teacher. It was industry-based chemistry. We were making plastics, kind of big manufacturing plant type things. And so because you're working in industry with people that aren't always chemists, we tend to call them starting materials and ending materials. I try hard to say reactants and products, but I like to throw it on the screen just so that if I accidentally say starting materials, ending materials, you know what I'm referring to. Another thing we're going to have to start taking into account are the phases of matter. We represent them with subscripts that are inside parentheses. We have gas, solid, liquid. You're probably familiar with those. Aqueous you may not be familiar with. Aqueous is what happens when we have an ionic substance that we've dumped in water, and it's what we call soluble. So the water molecule gets in between and disrupts that bond, and so instead of a bonded compound floating around, we now have the ions separated, an individual floating around in the water. So that is another phase that will be important later in the chapter. Sometimes you may have every single thing in the reaction be a gas. Sometimes every single thing might be an aqueous. Sometimes you may have some liquids and some solids. It could be a mixture of any of these. When we're writing our formulas, it's important that we remember that some compounds come as diatomics. So these elements you see here are not going to be found naturally by themselves. You're not going to find a hydrogen by itself, or a nitrogen by itself, or an oxygen by itself, etc. They're going to come as a pair. They're stable that way. So if I say nitrogen gas, you need to know that that's N2. Otherwise, you won't be able to balance your reaction correctly because you have a wrong formula. So there's a little mnemonic. It's kind of silly. It's called horses need oats for clear brown eyes. And you can see eyes is in quotation marks because it doesn't quite work with our letters. Hydrogen is horses, nitrogen is need, oxygen's oats, fluorine is for, chlorine is clear, bromine is brown, and then iodine is eyes. So it's not perfect, but it is the classic mnemonic for this. You do need to memorize these. So somehow make a note in your notebook. Make sure you don't forget that you need to know these formulas. All right, let's get on to the rules for balancing. Now that we kind of have some key terms, we're going to go over some rules. I'm going to have some suggestions and also some expectations for what I want to see when I ask you to show your work. So we always write the skeleton equation out first. Sometimes they may give that to you if you're lucky. Other times you have to write it, which means you have to know how to write your formulas, which means you need to know your ions and things like that. What you're going to do is you're going to count how many atoms are on each side of the reaction arrow. You're going to see how many do you start with and end with. If it matches, you're all done. If it doesn't match, what you're going to do is you're going to start putting in coefficients, the big numbers in front of the compound. Just try to help balance out those numbers. You're never, ever, ever going to change your subscripts. Those are locked in stone. What I always tell people is you need to have a valid, correct formula, and then you never change it. If you change those subscripts, that means you're changing the formula. So the only thing you can change is how many molecules you have with a coefficient. You cannot change which molecules you have, so be a little bit careful about that. Then you always want to double check that you used the smallest numbers possible to balance your equation. We want to have the simplest version of everything. So if you have a 2 and a 2, that would reduce to a 1 and a 1, for example. So always be on the lookout for reducing down your coefficients if necessary. And number 5, the part that nobody wants to do, you gotta check your work. These problems, they can be hard because you're counting so many different objects and you're changing your numbers so much, you may miscount. And so you always want to take 5-10 seconds, double check, and ensure that you're going to get that problem correct. It's going to feel crummy if you miss points because you miscounted something, right? And then the last rule, big important rule, you got to use pencil for this. The very nature of balancing is a back and forth process. You change one thing, it gets messed up. You change something else and it gets messed up again. So you have to use pencil for this. I'm not going to look at scribbles. You scribble things out because you're using pen. I'm not going to deal with that. Use pencil. All right, the next slide is going to go over some suggestions that I have. And you're going to see at the top I say tips for balancing that sometimes help. They don't always help. Some are just going to be hard. Sometimes what I tell you to do at the end might make things easier to do at the beginning. These are just tips. I've done this for a very long time and I've kind of noticed the things that tend to make balancing easier. and the things that tend to make it go faster. So for the most part, the things on this list will be helpful. The first one on this list up here, stuck, erase and start over. Always helpful. If you make one small mistake somewhere, you can just get in this cycle of trying to fix an equation and you can never fix it because something earlier went wrong. And so you're going to start trying and erasing over and over, and you just need to start from scratch. Erase everything, recount everything, and start over. I like to try to balance the atoms that appear in the fewest number of places first. You may have elements that are only in one compound on each side, versus elements that show up in 2 or 3 compounds on each side. If you focus on the ones that are more unique, that happen in fewer places, you're going to be able to kind of change fewer things at a time, so it's a little bit easier. I find it easiest to leave the diatomics until the end, typically. The diatomic elements tend to appear in multiple places, and often if you wait until the end, they will end up either getting fixed by themselves, making a change somewhere else will actually fix your diatomics, or it will be one last thing at the very end to change in a very simple way. I tend to think that the oxygens are the hardest to balance, oftentimes because you get weird combinations of even and odd numbers. Our brains, for whatever reason, tend to have an easier time with even numbers. We can balance things with 2s and 4s and 6s much easier than things with 3s and 5s and 7s. And because of the types of compounds that oxygen likes to make, like water, for example, we tend to get odd numbers. So oxygen is often a good one to leave towards the end as well. Some people like the next tip, some people don't. I think that it makes things go much faster, but you do have to pay a little bit more attention. So sometimes you're going to have polyatomic ions in your formula, and it may be easier to think of them as a chunk that travels around and doesn't get broken apart. And so rather than trying to balance each individual atom inside the polyatomic ion, you can try to balance the entire chunk as one piece. That might make things go a little bit faster. The last part is a tip that makes balancing a certain type of reaction way easier and way faster. Sometimes it may be unnecessary, but because our brains like even numbers, it will help us go faster. The problem is you haven't learned what a combustion reaction is yet. So when we get to one of those examples, I'll point it out. A combustion is what we get if we have a hydrocarbon mixed with oxygen. It burns and produces carbon dioxide and water. And those are hard to balance because we get that odd and even combo that's tough. So by putting a 2 in front of your hydrocarbon, you will force every number in the problem to become an even number, and then you can go a lot faster. You may have to reduce your coefficients at the end. It may not have been necessary to double everything, but sometimes it is. And even if it wasn't necessary, it'll be a lot faster. All right, so for these practice problems, I need you and expect you, and I'm going to require that you show your work the way that I do it. Okay, now yes, eventually you're going to be able to do these in your head for the most part, but there are going to be ones that are pretty tough and that you're going to need to be able to show your work because it's more challenging or because it's a problem that I'm asking you to show your work on for a quiz. And if you don't show your work appropriately to be able to convey your thought process, then I'm not going to be able to give you points for that problem. So we do need to practice showing our work. Use pencil. Okay. Big reminder. The last thing that I just kind of want to tell people before we do some examples, related to this use pencil concept is one of the things that's hard about balancing equations is you make one change to fix an element and something else gets way worse. So, I thought this was a funny meme, Game of Thrones here, right? It's going to get worse before it gets better. Sometimes you make one change to your balanced equation and things are looking worse and worse and worse, and your numbers are getting worse and things are getting less balanced, and then all of a sudden you put one last coefficient in and it just perfectly fixes everything. And so I tell people, like, don't panic, okay? Make sure you're using pencil because you will be going back and forth and back and forth. It'll get worse, you'll fix it, it'll get worse, you'll fix it, and it'll have this back and forth rhythm to the problems. So don't panic, okay? Let's do some examples. All right, so let's give this one a try. The first thing we're going to do is underneath the equation, we're going to make a list on each side of the arrow of the atoms that are present. So you can see we have zinc, we have sulfur, and we have oxygen. So I'm just going to write that on each side of the arrow. I highly suggest that you keep the order of the elements the same on each side. I've noticed over the years people get fewer mistakes if they do that. So now we're going to count how many we have of each on each side of the arrow before we try to do anything. You need to know where you're starting before you try to change anything. So I can see here I have 1 zinc, I have 1 sulfur, and over here I have 2 oxygen atoms. On this side I have 1 zinc, I have 1 sulfur, and I only have 1 oxygen atom. So you can see looking at these numbers that the first 2 look fine, but we do need to fix the number of oxygens. I can't subtract, right? I can't get this 2 to be any smaller. We are not allowed to use fractions. Okay, we have to use whole coefficients. We're not going to have part of a molecule. So all I can do is make the other side larger. So I need to put a coefficient in front to get this number to increase so that it matches. So I'm going to put a 2 here. Now I have 2 oxygens. But you may notice I fixed one thing and I screwed something else up, didn't I? I totally messed up the zinc. I don't have 1 zinc anymore. Now I have 2 zincs. I fixed one thing and then it got worse, right? Back and forth. So now we're going to go back to this side and we're going to try to fix the zinc. I'm going to put a 2 in front. Now I have 2 zincs, so that's all better. But I messed up the sulfur this time. So now I have to update that as well. Now I have to go back to this side and I'm going to put a 2 there. Now I have 2 sulfurs. Just so that you know, it's just a coincidence that we used the same number each time. That will not always be the case. That's just a coincidence. Now, the part that nobody wants to do, the part that would catch a lot of mistakes and would save a lot of people from losing points on things like quizzes and tests, going back and recounting once you think you're finished. So I put a line next to the ones I was working on, and I'm going to put my new count on this side. So I'm going to start from scratch. Okay, I got 2 zincs. Now I got 2 sulfurs. I have 2 oxygens. Okay, that looks good. Come over here. I got 2 zincs. I got 2 sulfurs. I got 2 oxygens. I double check that everything matches. I used whole numbers for my coefficients. I can't reduce these, okay, because there's a 1 here, right? You can't reduce it if there's a 1 there, so it's totally finished. So it's good to go. Okay. Let's do another one. The first thing we're going to do is we're going to make our list of our elements. We have copper, silver, nitrogen, and oxygen. I'm going to drop that list below on each side of the arrow. I have 1 copper, I have 1 silver, I have 1 nitrogen, and I have 3 oxygens. On this side, I have 1 copper, I have 1 silver, but look, I have to distribute. There's 2 nitrates, so that means I have 2 nitrogens. That means if I distribute here, I have 6 oxygens. So I have a couple of things I have to fix this time. Personally, I like trying to leave the oxygens till the end, or at least, as late as I can. I'm going to try to fix my nitrogen first. Another thing I'm going to try to keep in mind is if you notice, I have a nitrate ion package on this side, and I have a nitrate ion package on this side. The nitrate is not breaking apart. It's traveling as a package, right? And so if I look here, I have 2 of these packages. So in my head, I'm going to think about trying to balance that as one whole chunk. If you don't like that, then just focus on the nitrogen. You have 1 here, and you have 2 on this side. If you need 2 nitrogens, put a 2 there. We fixed our nitrogen, but look what happened. We messed up our silver, didn't we? Now we have 2 silvers. We also changed our oxygens, but look what happened. On accident, without really meaning to, I fixed that as well. So I was able to fix 2 things at a time, which is kind of nice. But now I have to fix that silver. So I'm going to go back to the other side, put a 2 there, update my count. Now I think I'm done, so I'm going to drop my lines. I'm going to just recount. I'm not going to be lazy. I'm just going to do it, okay? Please, please, please check your work. I got 1 copper. I got 2 silvers, 2 nitrogens. 2 times 3 gives me 6 oxygens. On this side, I have 1 copper. I have 2 silvers. If I distribute here, I have 2 nitrogens, and I have 6 oxygens. So we are good. Okay. All right, what I'd like you to do is I would like you to make your lists below on each side. I'd like you to count up all your atoms on each side of the reaction. And then I want you to pause, and then we'll balance it together. But just see if you can get the first couple of steps done. So we have hydrogen, we have phosphorus, we have oxygen, and we have sodium. The thing that's tricky is if you notice, hydrogen and oxygen show up in multiple places on each side of the reaction, right? So I don't have 3 hydrogens, I actually have 4. I have 1 phosphorus, I have 1 sodium. Now I don't have 4 oxygens, I actually have 4 plus 1 is 5. On this side, I have 2 hydrogens, I have 1 phosphorus, I have 3 sodiums, and I have 4 plus 1 is 5 oxygens. So I have a couple of things to fix here. I'm going to leave the hydrogens until the end because they tend to be a little bit trickier. I'm going to focus on the sodium because the sodium only shows up in one place on each side. So I can only increase my numbers. So that means I'm going to be working on this side. If I want 3 sodiums, I put a 3 there. But I've messed up a whole bunch of things, haven't I? Now I don't have 5 oxygens, I have 4 plus 3, which is 7. I've also messed up my hydrogens. 3 plus 3 is 6. Things got a lot worse, didn't they? Okay, now we messed more things up. We're going back and forth. Let's go to the other side now. Okay, let's put a 3 here. Now, that's going to fix my hydrogen, isn't it? 3 times 2 is 6. And now it's going to change my oxygens also. 4 plus 3 is 7. So with one coefficient, I was able to fix multiple things, which is kind of nice. And if you noticed, I left those hydrogens and oxygens towards the end as well. I think I'm done. I'm going to draw my lines. I'm going to recount. Be very careful to recount, especially when you have elements in multiple places. That's when we tend to make mistakes. So 3 plus 3 is 6 hydrogens. I still just have 1 phosphorus. 3 sodiums. 4 plus 3 oxygens gives me 7. On this side, 3 times 2 is 6. I have 1 phosphorus. I still have 3 sodiums. 4 plus 3 is 7. Okay, and it's good. All right, now you may notice that we tend to use relatively small numbers. You know, we don't typically end up with giant coefficients, but you could. There's nothing that says you can't have large coefficients. And, you know, the problems we've been doing so far have relatively small number of atoms, right? But there's nothing that says they can't be large numbers. Some problems are more complicated. Some are going to have larger numbers. That does not mean something's wrong. It just means you need to be a little bit careful and double check your work. Make sure you're adding things up correctly. We see a lot of addition mistakes and a lot of multiplication mistakes, right? So always be a little bit careful. I mean, I don't care if you use a calculator. I don't care if you count on your fingers, right? As long as you get the right answer, who cares? So just be careful with your adding and your multiplying. You'll see this on the next problem. Some of our numbers are going to get a little bit larger this time. So what I'd like you to do is see if you can balance this one. Don't let the large numbers that you're going to get for one of your elements freak you out. One of them will be a little bit larger than typical. You can go ahead and pause the video to give yourself time to do this. It might take a while. Use pencil so that you can erase if you need to. If you feel like you've gotten terribly stuck, then erase everything and completely start over. Okay? All right, we have calcium and phosphorus, oxygen, hydrogen, and sulfur. A lot of atoms. A lot of things to keep track of. Let's count everything up. We have 3 calciums. Make sure you distribute. You have 2 phosphorus. Now be careful with your oxygens. 4 times 2 plus another 4 over here. You have 12 to start with. That's a lot of oxygens. Now the hydrogens, you got 2 and you have 1 sulfur. On this side, you have 1 calcium. You have 1 phosphorus. 4 plus 4 oxygens, you got 8. And you have 3 hydrogens and 1 sulfur. So where do we start? Now, I might start with one element and you may have started with a different element. It doesn't matter. Maybe, you wanted to start with calcium and I start with phosphorus and someone else starts with, the hydrogens, whatever. Technically, it doesn't matter. Okay, whatever pops out at you, whatever feels easiest for you, you can go in that order. This is what I did. I put a 3 here and I fixed the calcium first. That's just what popped out to me. In the process, I messed up my sulfur. Now I have 3 sulfurs. And I messed up oxygen. Be careful here. 3 times 4 plus another 4. Altogether, that's 16. These numbers are getting pretty big. Now, let's fix something else. Let's put a 3 here, and let's fix the sulfur. That also messed up my hydrogens. I have 6. And it messed up my oxygens. Now on this side I have 4 times 2 plus 3 times 4. Now I'm all the way up to 20 oxygens. That doesn't mean it's wrong. It just means it's more complicated. Okay? Now, let's put a 2 here and finally fix that phosphorus. And now let's count our hydrogens again because we messed those up. Now we have 6. And now let's count our oxygens. 3 times 4 plus 2 times 4. Add that all up. If you need to use a calculator, if you need to use your fingers, do it. You get 20. Big number does not mean it's wrong. Just means be careful. Think I'm finished. I'm going to draw my lines. Okay, 3 calciums. I got 2 phosphorus. 4 times 2 plus 3 times 4. That's going to add up to 20. 3 times 2 is 6. I got 3 sulfurs. Okay, this side. 3 calciums. 2 phosphorus. 3 times 4 plus 2 times 4 is 20. I have 2 times 3 for my hydrogens, and I have 3 sulfurs. Oh, kind of a terrible problem, but we did it. Lot of elements, lot of atoms, lots of back and forth, but it worked. Okay. All right. Now this, if you don't know, this is a combustion reaction. If you look, we have oxygen gas. It's reacting with a hydrocarbon. A molecule that has carbon and hydrogens is called a hydrocarbon. It's a type of fuel source, okay? This is going to combust, burn, right? And it's going to make water and carbon dioxide. Combustion reactions always make water and carbon dioxide. That's part of their definition, okay? So just a tip, if you remember from earlier in the PowerPoint, I suggest that when you have a combustion reaction, to make your life easier, to make things balance faster, to force these to be even numbers, which is easier and faster for our brains, what you're going to do is put a 2 in front of your hydrocarbon before you balance, okay? It may not be necessary, but it will force everything to become an even number. And hydrocarbons have a bad habit of being odd, even, mismatched numbers. Because if you look, we have an even number of oxygens here, but we have an odd number of oxygens on this side. It gets a little bit hard. So I find most people do much better by putting the 2 here before they begin. Now you're going to go ahead and you're going to count up your elements. We have 2 oxygens, we have 2 carbons, and we have 8 hydrogens. I'm just pretending that this is how it starts. Now over here, I have 3 oxygens, 1 carbon, and 2 hydrogens. So let's start fixing things. Let's fix that carbon. Let's put a 2 over here. Let's update our oxygens. Now we have 4 plus 1 is 5. Well, it doesn't seem much better. Let's move on. Let's try fixing the hydrogens. Let's put a 4 here. 4 times 2 is 8. And now I changed my oxygens also. So 4 plus 2 times 2. Now we have 8. Now to fix the oxygens, if you look at the reactant side, oxygen only appears in one place. So now I can fix my oxygens with one coefficient, focusing on one molecule. It's going to be a much, easier thing for me to do. So now I know I'm going to put a 4 there. Now at this point, people count. And they're like, yeah, look, good, it matches, yay, I'm done. No, you're not done. You forgot something. What do you notice about those coefficients? We can reduce them, can't we? They all have a common multiple, right? So we got to get those shrunk down. It's not going to be 4, 2, 4, 2. That's not the simplest, set of numbers. I'm going to reduce them. This becomes a 2. This becomes a 1. You don't have to put the 1. This is a 2. This is a 1. Now that's the finished balancing, okay? So it turned out it wasn't necessary for me to start the problem with a 2 in front of my hydrocarbon. That wasn't necessary, but it sure made it easier for my brain. I got to do even numbers. That's better. Okay, and then I just reduced it. So while this reduction step seems like extra work, you gain the time back, right? Yes, it's extra time to reduce it, but if you can balance it way faster, you're still going to come out ahead, aren't you? So now that we reduced it, now it's finished and it's balanced. All right, you try this one start to finish all by yourself. You can pause the video if you need some more time. And then when we're finished, after I show you the answer, I'm going to explain how we can turn these types of balancing problems into multiple choice questions. Because when I have, 200 students trying to look at a bunch of balanced equations, I would be grading papers for years, right? So there's a way that I can check that you can do this in a much more efficient way with a multiple choice question. So I'll kind of show you how we do those so you get some practice with that. All right, so we have chlorine, we have sodium, we have bromine. Not too many elements this time. That's kind of nice change. We have 2 chlorines, we have 1 sodium, we have 1 bromine. We have 1 chlorine, 1 sodium, 2 bromines. I'm going to start by putting a 2 here to fix my chlorines, but I messed up my sodium at the same time. Then I'm going to go back to this side, fix my sodium, messed up my bromine, but look, I didn't mess it up. I actually fixed it without even trying to, which is kind of nice. So I think I'm finished. Nice small numbers. 2, right? We've got 2 chlorine atoms, we have 2 sodium atoms, 2 bromine atoms. Over here we have 2 chlorines, 2 sodiums, and then over here we have 2 bromines, so we're all finished. So the next part is going to be seeing how we can turn this into a multiple choice question. There's 2 pretty common ways to do this. The first is me asking you, what is the sum of the coefficients? So I'll give you a hint. The answer is not 4. The answer is 6. The reason the answer is 6 is that we cannot forget that even though it looks like there's nothing here, there's actually a 1 here. Just like in math class, when it's 1x and you don't put the 1, it's not that the 1 isn't actually there, it's just that we're being lazy and we're not putting it. So yes, there is a 1 here. Same with over here. So when I add up 1 plus 2 plus 2 plus 1, I get a sum of 6. The other way to do this is I could be asking you to list the coefficients. You list from left to right, you separate them with a comma. So the answer would be 1, 2, 2, 1. You can't forget on either of these methods that there is a 1 present. Okay? Last little reminder, I'll say this over and over and over, use a pencil, stay calm, don't panic, when your numbers start getting bigger, go back and forth. Remember, it's going to look worse and then it will get better. If it's looking really, really wrong, then just erase the whole thing and start over. Okay? All right, everybody, that's it. I hope it was helpful. Bye.